For slide 4, we have an inelastic collision between two spheres. We are given the mass of the first sphere. The second mass is unknown. We do know the initial velocity and final velocity, not in numerical terms, but as a comparative velocity. So the velocity final is going to be reduced to 1/3 the original starting velocity. So our goal in all this is to figure out what is the unknown mass for the blue sphere. So this is an inelastic collision, and we can write out our equation to keep things simple and color-coded. Let's just do m v naught, and then plus our second mass. This is our blue mass. It's moving with a velocity of 0, so that part of the equation is going to drop out. After the collision, we have the combined mass, which is going to be m1, and let's go ahead and label these m1 and m2. So m1 plus m2. And then they're moving at a final velocity of v naught over 3. So once we clean this up, we can see that this will drop off and go away. And we want to try to get m2 by itself. So we're going to multiply both sides by the reciprocal of v naught over 3. So the reciprocal is 3 over v naught, and we'll multiply the left side by 3 over v naught. So notice how this is going to reduce away, and on the left side, v naught will reduce away. So what that leaves us with is 3 m1 would be equal to, and now I can take the parentheses out, m1 plus m2. Since we're solving for m2, we'll move this around, and we're going to subtract m from both sides. So 3m1 minus 1m1 would be equal to m2, which is to say that m2 is going to be twice the mass, because 3 minus 1 gives us 2. So this is twice the mass 1. So in my case, I'm just going to double my original mass to 6.41. 6.42.